The end behavior of a function describes how the function behaves at either end of the graph, or what happens to the value of f of x as x increases or decreases without bound. You can use the concept of a limit to describe end behavior. So what we can see here is that f of x is getting bigger and bigger. It's headed upward toward positive infinity as we head to the left towards negative infinity for the x value. The y value, the f of x, is headed up to positive infinity. So we would write that like this. We would say LIM for limit of the function f of x. Underneath that statement, we say x goes to negative infinity, so that we're telling our audience which side of the graph we're talking about. So headed towards negative infinity means the left side of the graph. And the left side of this graph, the function is headed up to positive infinity. So we would say positive infinity. On the right side of this graph, and we are headed down towards negative infinity. So as x gets bigger and bigger, goes to positive infinity, the function gets smaller and smaller and smaller and heads to negative infinity. So we would say the limit of the function f of x as x goes to infinity equals negative infinity. It heads downward. The left end behavior as x becomes more and more negative is written like this. The limit of the function, and underneath you say x goes to negative infinity, and then you would say equals whatever value. The right end behavior, we say the limit of the function f of x as x goes to positive infinity equals whatever value it approaches. So if we take a look at our graph, in number 13, this is a quadratic. This is your parent function, the parabola, with the vertex as its origin. With its vertex at the origin. So if we say the limit of the function as x goes to negative infinity, so the left side of this graph, well, if I head it out to the left, this function is headed up to positive infinity. And then if I say the limit of the function as x goes to positive infinity, all right, so looking at the right side of the graph, well, the right side of this graph is also headed up to positive infinity. All even polynomials will head the same direction. Both ends, the ends are even, as we say, they're both headed the same way. So because this one's positively oriented, both the left and the right side head up to positive infinity. Number 14 is an odd degree polynomial. The ends are going different directions. So this time, the left side of the graph is headed down to negative infinity. So I'm going to say the limit of f of x as x goes to negative infinity is negative infinity. The left side is headed down. Then I'll say the limit of the function as x goes to positive infinity. So this means the right side of the graph as we head to the right. So as we head to the right, this function's headed up to positive infinity. Odd degree polynomials will always have opposites. They go different directions. Think of the DD and odd. One's going down, one's going up. So one limit would be headed down to negative infinity, the other would be headed up to positive infinity. So we'll see that again here in 15. This one is just negatively oriented. So this time, if we talk about the limit as f of x as x heads to negative infinity, the left side of this graph, so again, heading out to the left, this function is going up this time to positive infinity. And the limit of our function as x goes to positive infinity. So if we head out to the right, this function's ultimately headed down to negative infinity. So this is a negatively oriented odd function. It's falling from left to right. So now the left side of the graph heads up. The right side of the graph heads down. In number 16, we have a rational function, or in Precalc, we will be calling it a reciprocal function. The x is below the fraction bar if we would have the equation for this. We see a vertical asymptote here, horizontal asymptote here. But we are looking for the end behavior. So the limit of our function as x goes to negative infinity Well, the left-hand side, we see we're leveling out to that horizontal asymptote that's occurring right at x equals 3. So the left side of the graph is approaching the value of 3. If we look at the right side of our graph, so the limit of f of x as x goes to positive infinity, we are also leveling out to 3. So on the left side, we're leveling out, sorry about that. We are leveling out just below 3. On the right side, we're leveling out just above 3. So both sides have a limit of 3.